Hi everyone, in this video we, Group 3, are going to present about Newton's law of cooling, which is one of application of first ODE. The first one, introduction and problem statement.
Assalamualaikum warahmatullahi ta'ala wabarakatuh, and hello everyone. My name is Zari Ashraf and I am from Group 3. From the assignment given, we Group 3 choose question 3 as our task. The question states that it was noon on a cold December day in Cameron Highland, 16 degrees Celsius. Detective Musa arrived at the crime scene to find the sergeant leaning over a body. The sergeant said that there were several suspects. If only they knew the exact time of death, then they could narrow down the list. Detective Musa took out a thermometer and measured the temperature of the body, 34.5 degrees Celsius. Then he left for lunch. Upon returning at 1 p.m., he found the body temperature to be 33.7 degrees Celsius. When did the murder occur? Studies say that human body temperature is 37 degrees Celsius. The body tightly regulates its temperature through a process known as thermoregulation, which allows the body to keep its temperature within certain boundaries, even the surrounding temperature is very different. By using the first order differential equation, one can use the temperature of human body to find the time of death of a person, where the rates of change can be found by using the differential, integration and substitution. For the formula to work best, a freshly discovered body temperature is taken for several hours after one heartbeat has stopped beating. The body core temperature drops toward the ambient temperature. By obtaining the difference of the temperature drops for an hour, we can find the time of death of a person. The problem statement of this project is to determine on how the equation of first order differential equation are formed by using differentiation, integration and substitution method to find the death time of the person. The purpose of this assignment is to investigate the crime scene and apply the application of mathematical relation of differentiation, integration and substitution which to find the initial death time of the person.
Next, for methodology.
Overview of the method used to solve the case study. Methods that related according to this project are differentiation, integration, and substitutions. These three methods are used for forming and solving the problems in this case study. Differentiation is a method that allows us to find rates of change. For example, in this case study, differentiation helps us to find the rate of change of temperature. As you can see, this equation is based on the formula of Newton's law of cooling, where T represents the temperature of the object surrounding and M represents the temperature of an object as a function of time. Next, for integration, integration is the reverse of differentiation. When integrate, a constant needs to be added. For example, the integral of 3 is equal to 3x plus c, where c is a constant. This symbol is mean the integral of n dx is means by with respect to x. And lastly, for substitution. Substitution is the method of solving by substitution, works by solving one of the equation for one of the variables, and then plugging this back into the other equation, substituting for the chosen variable and solving for the other, then can back solve for the first variable. For example, if we have two equations and then we arrange y to become like this and then substitute y into this equation, and you will get x, where x is equal to 5, and then substitute x into this and you will get the value of y is equal to 4.
Next, we go into the manual calculation. So, the capital letter of t over dt equals k multiplied with capital letter of m minus t is the general equation for the Newton's law of cooling. So, the capital letter of T over dt represent the rate at which the temperature change. Capital letter of T represent the temperature of the objects surrounding, which is constant value. For example, like the temperature of body is 37. The value is constant. The temperature of an object as a function of time represented by capital letter of M. So, first, as the differential equation is separable, we can separate the variable and we can obtain this equation, which is the capital letter of T over capital letter of M minus capital letter of T is equals to K dt. After we get the equation, we can integrate both sides. And then after we solve the equation, we can get the value of capital letter of M, which is capital letter of M is equals to A exponent kt plus capital letter of T. After we get the value of capital letter of M, we can solve a value of A by using the initial condition. We assume the time at 0 seconds. Finally, to determine the value of K, we just substituting the information in the equation that consists the value of capital letter of M and A. Then we can find the period.
Newton's law of cooling states that the rate at which object cools is proportional to the difference in the temperature between the object and the object surrounding. In this case, we use two parameters, which are the temperature of the body at noon, which is 34.5 degrees Celsius, the temperature after 1 hour, which is 33.7 degrees Celsius, and the surrounding temperature, which is 16 degrees Celsius, and the normal body temperature, 37 degrees Celsius. The calculation is based on the first-order linear differential equation formulated by Newton and then was modified with a two-exponential model by Marshall and Hall. Based on the formula, the time of death was 9:08 a.m. Noting that the difference in temperature of the body is small, which is 0.8 degrees Celsius, we conclude that the rate of heat loss is proportional to the temperature difference. The temperature is plotted against time for the cooling of human body. Coming up next, our conclusion. So, as we can see, differentiation usually used to study the small change of a quantity with respect to unit change of another. However, a differential equation is full of surprises if you try to understand it properly. As an example, we use Newton's law of cooling, which is represented by the differential equation, and solve it by using separable equation method, since it is separable. So, to conclude, the differential equation helps us to solve problems in real life. As shown in the previous slide, we can determine someone's death by using the first order differential equation. Last but not least, the differential equation can be implemented to solve population growth, radioactive decay, series circuits, economics and finance, and etc. The last one is the references that we referred to complete the assignment.